Hello everyone, I'm Yo from University of St. Andrews. This work is in collaboration with many co-authors from different institutes as shown here. Today I will talk about JINSense. The first motivation is smart glass the future? Actually, I'm not sure about that, but we all know that the big companies are working on smart glass nowadays. So maybe it will become the next dominant form factor in the near future. And when that happens, we will need a better way to interact with these smart glasses. Next is about Midair Gesture. Actually, they are not new, and they are already included in many smartphones such as Pixel 4, LG, and Huawei Mate series. Some people might say that it is just a gimmick, but I think it can be quite useful sometimes. For example, when your hands are dirty, especially during this COVID era, we shouldn't be touching things outside in the public. So we will need this kind of touchless interaction. Therefore, in this work, we propose JINSense. It is about exploring a new sensing technique for device equipped with electro-oculography sensors, EOG. We repurpose the EOG sensors embedded inside a JINS MEME smart eyewear. As shown in the figure here, you can see there are 3 electrodes, 1 on the nose bridge and 2 on the nose pad. It was originally designed to detect eye movement. However, we repurpose it to detect mid-air hand gesture, to sense human proximity, rubbing action, and to differentiate materials. So these newfound sensing capabilities enable a various type of novel input and interaction scenario for such wearable device. So let's look at our setup here. I leave the glass on top of a desk and I visualize the raw data on the screen. And when I make hand gesture, such as swiping, left push and pull, rotation, you can see that the raw signal are changing and they are also quite unique. So we believe that using this, we can detect mid-air hand gesture, and we made an initial prototype. First, we stream the raw signal from the JINS MEME device to a laptop using Bluetooth. Now let me show you the prototype. You can see that when I swipe, it can detect correctly left or right gesture, and also the vertical gesture, either up or down. Besides gesture, we also observe some very interesting phenomena, especially for the plastic bottle. So when I was trying a plastic bottle waving on top of the glass, it actually generates the higher amplitude signal than using the hand. And another more interesting phenomena is when I try to rub the plastic bottle from a distance, almost like 1 meter away, you can see on the screen that it is still detecting the action and it generates the unique signal. So I think we can detect a different kind of material and also the rubbing action. Next is about water sensing. So when I fill the bottle with water and try to wave it on top of the glass, actually it generates a small amplitude signal. But when I remove the water, it causes a higher amplitude signal, stronger signal without the water. So I think we can also use this to detect whether there's water inside a bottle or not. Let me talk about more potential application and use cases. So we can interact with the IoT device. Like before going to bed, a person usually removes the glass and put it on the bedside table. And when the alarm rings, he can just wave to dismiss the alarm. Or a user might fold the sunglass and put it in front of the pocket or the collar hanging like this. So the user can perform mid-air hand gesture to interact with the smart glass. Also, it can becomes a multi-purpose smart sensor for material recognition, water level detection, and dryness detection. In the future, we want to explore more use cases that are uniquely enabled by our technique, including touchless, discrete, and context-aware interaction. We want to implement and of course to evaluate and study it. In conclusion, we have explored new ways to exploit and repurpose existing EOG sensors to achieve new sensing. The key takeaway here is there is no need to add new sensors to a device, and it is possible to reuse existing sensors. Thank you very much.